All right, we are going to take a look at using an arrow diagram to sketch a graph of a function. So I've started out here with a table of points. I didn't want to use some function that we already know, so we'll just use some other random relationship between inputs and outputs that are captured by this table of values that are here. So inputs comma outputs at point -5 comma 12 is on this graph. I know this isn't a very big graph, but that is what the graph of this thing looks like if I just connect them with points or with segments. Okay, so the function that we want to get a look at, though, is this g of x function right here that's got all kinds of stuff going on there. And so the way that we're going to use the arrow diagram is we're going to start like we always do when we're building one and pick an x and start describing what is happening to that x. If I go in here, here's where the x is. The first thing that's happening there is a division by 3. It gives me an x over 3, which I then add 1 onto. That x over 3 plus 1 then goes into the function f. Okay, I only know about these 5 points on f, but I know them. But I know exactly those 5 points on f. Then I'm going to multiply it by 2. The way I always do with the subtraction stuff is get that multiplier, do a sign change, and then add 3 on. So this is the arrow diagram for the function g. G takes all of those steps. And what I can do then is I've got to have something that I know on there. Well, I've got this arrow f in the middle, and I know about 5 points on f. I know that an input of -5 leads me to an output of 12. -2, -3 is a point on that graph. 1, 7, 4, 0, and 6, -5. Okay. Now, going to the right here, I've got a bunch of inputs here in the 12, the -3, 7, 0, and 5 that are at the input side of this multiply by 2 arrow, so I'm just going to multiply them by 2. This becomes a 24, this becomes a -6, 14, 0, and -10. The next arrow says change the sign on all of those, so that's a -24, that's a 6, that's an, oh, sorry, -14, should be an easy one to do, 0, and 10, and then finally it says add 3 to all of those, so that'll put me at a -21, a 9, -11, 3, and 13. On this side over here, I need to move back this direction, so I'm going to need arrows going this way. We know from what we've done with this before that that's going to make that a subtract 1, and this is going to be a multiply by 3. So if I do that, -5 minus 1 is -6, -2 minus 1 is -3, 0, 3, and 5. And then this says multiply all of those by 3. And what I get then is a new list of points. The point -18, -21 will be on the graph of g. The point -9, 9 will be on the graph of g. I'll have 0, -11, 9, 3, and 15, 13, and I will just plot those points on the new graph rather than try to spot those necessarily in here. I do have a new graph of that I will pull up. All right, and I went and grabbed this. The one in the dashed blue lines there is our new one. We can see I used the table feature in Desmos to do these graphs for me, but I could have easily done this on a piece of graph paper. You can see the original graph right in here. There was my original graph of the function f, and then here's my new one connecting those points with for the function g. And so this is the function g, this was the function f, and so all of these changes that I made to there, this is the next thing that we're probably going to be talking about is something called transformations. And we can begin to get an understanding of the transformation from there. But we also see that all we need is the right points on a function, and then we can do something like this funny looking function up here becomes something that is easily something that we can work with and come up with ideas of what these new graphs look like. So I want you to think about that for a little while, what happened there. Watch it as much as you need to make sure that that all makes sense to you.